Hi, I'm an old guy and I do maths. Today we're going to look at the sine rule, and this is really just an introduction to it. So you come to the sine rule probably from two directions. One is that you've been doing trigonometry and mathematics and you've got to the point where you are dealing with non-right angled triangles, which is really where the sine rule comes in. And at the same time, you might see something called the cosine rule, which will be the subject of another video. The other direction that you may have come from is physics, where you might have been delving into triangulation. And triangulation is based upon the mathematics of the sine rule. So whichever way you come, you wind up looking at the sine rule and trying to figure out what exactly is going on. So the first thing to say is that you use the sine rule when you're confronted with non-right angled triangles. It doesn't work for every single one. It works for a substantial portion of them, and when it doesn't work, you can use a thing, as I said, called the cosine rule, which exists. But we have to start somewhere, and we're going to start with the sine rule, because the sine rule only has one or two iterations, one or two versions. The cosine rule has six. If you want to go through them all, it's got two basic ones, but it's got a few extras. Let's just put it that way, and you'll see when you look at the video. Okay, so what is the sine rule? Well, this is the sine rule. It says that the sine of A divided by A, so that's the sine of angle A, capitalized, over A, which is the length of a line, is equal to the sine of B over the length of B, and the sine of C over the length of C. Right. Now, generally when you're working with the sine rule, you only need two of these. So you can have sine A and sine C, you can have B and A, B and C, any combination. You really only need two. The purpose of the rule is simply to demonstrate that these ratios are all equal, and therefore if you have three parts, say for instance 3 parts of this formula, you can find the fourth part. So if you've got the sine of A and the length of A, the sine of B, you can find B. If you've got the sine of B and B, and you've got the length of A, you can find the sine of A and get out your calculator and find out what that angle is. Okay, so what are these things? Well, when I started out, the first thing that the teacher in our class did was tell us how to name a triangle. And this is how you do it. So I have here a triangle that is non-right angled, and that's demonstrated by the fact that I have these symbols in each of the corners. So don't think for a minute that this is a right angle. It's not. If it were a right angle, we'd be back to SOHCAHTOA and the trigonometry that you're used to. Okay, so it's a non-right angled triangle. And how do we name it? Well, each corner, each angle, gets a capital letter. I do this clockwise. I start on the left and I work around A, B, C. It's not important. You can start with A up here, you can start with A here. It really doesn't matter. What does matter is that opposite angle A, you have side A. Let me say that again. Side A must be opposite angle A, side B must be opposite angle B, and side C must be opposite angle C. That's important. Okay, so how do we put this to work? Right, So here's an example, and what I'm going to do is I'm going to do all the algebra for this, and it's easy enough for you to pick up a calculator and figure out what this actual angle is once I'm finished. A key thing in mathematics is the ability to estimate what your answer should be. This is a little bit of a tangent here, but we've got a side of 9, an angle of 40, we've got a side of 7, and we're looking for an angle here. If we get an answer that says 70 degrees, we know we've done something wrong, because it just should not be. In reality, I suspect that this angle should be smaller than that, depending, of course, on other factors. But if we've got a side length here of 9 and an angle of 40 degrees, I would expect that this angle would be sub 40, simply because this line is not so long. Okay, so that's just a thing to keep you out of trouble. Right, let's get to work. So, as I said, with the rule, which is here, you usually only ever use 2 of these. And so what I've done here is I've deliberately set up A and C. So, what we know is we know that we're looking for the sine of the angle of A. So we'll start here. Sine of A divided by 7, that's over A, is equal to the sine of C, which is 40 degrees. So angle C is 40 degrees, over the length, 9. Now, we can find this value. The sine of 40 degrees is simply a matter of looking something up on a set of tables or in a calculator. So we know what this is. We've got a number for this. We obviously have these two. The thing that we don't have is this. So, a tiny little bit of algebra. The sine of A, this is how I write the word sine, just an S with a squiggle. I've got really terrible handwriting, and I apologize, but you'll get used to this, is equal to the sine of 40 degrees, that's C, over 9, and we're going to move the 7 times 7. And that's our answer until we bang it in a calculator and get a value for this. And what it does is it gives us the sine of this. It doesn't give us the angle, it gives us the sine. And your job then is to find out what the number here is the sine of, what angle it is. And as I said, I would expect it to be sub 40 degrees. Anyway, that's the nuts and bolts of the sine rule. The next example of this, I'm actually going to go through with a calculator. But just let me recap briefly. There are 3 elements to the sine rule. You usually use 2. You need to know how to name a triangle, A, B, B, C, C. It's always a good idea to draw your triangle and put the information in. So we have information about angle C, we have information about length C, we have information about length A, but not about angle A. So that's the thing we're looking for. So we start off with sine A over this length is equal to that the sine of that rather over that. This is a value we can find. A little bit of algebraic manipulation, and we get an expression which will give us the sine of the angle of A, and from that we can get the angle. Well, I hope that was helpful. As I say, there's going to be a fully worked example of one of these in the playlist, and the cosine rule will also be there. Thanks very much for watching. See you next time.